For decades, the exploration of our solar system left one of our neighboring planets, Venus, largely unexplored. But now, things are about to change. NASA recently announced that they have selected 2 new missions to Venus. Part of NASA's Discovery program, the mission aims to understand how Venus became an inferno-like world when it has so many other characteristics similar to ours, and may have been the first habitable world in the solar system, complete with an ocean and Earth-like climate. These missions are the final selections for 4 mission concepts NASA picked in February 2020 as part of the agency's Discovery 2019 competition. Following a competitive peer review process, the 2 missions were chosen based on their potential scientific value and the feasibility of their development plans. The project teams will now work to finalize their requirements, designs, and development plans. NASA is awarding approximately $500 million per mission for development. Each is expected to launch in the 2028 to 2030 timeframe. NASA will send 2 new spacecraft called DAVINCI Plus and VERITAS to Venus as part of its Discovery program. DAVINCI Plus, or Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, will measure the composition of Venus's atmosphere to understand how it formed and evolved, as well as determine whether the planet ever had an ocean. The mission consists of a descent sphere that will plunge through the planet's thick atmosphere, making precise measurements of noble gases and other elements to understand why Venus's atmosphere is a runaway hothouse compared to that of Earth's. In addition, DAVINCI Plus will return the first high-resolution pictures of the unique geological features on Venus known as tessera, which may be comparable to Earth's continents, suggesting that Venus had plate tectonics. This would be the first US-led mission to Venus' atmosphere since 1978, and the results from DAVINCI Plus could reshape our understanding of terrestrial planet formation in our solar system and beyond. The next one is VERITAS, or Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy. VERITAS will map Venus' surface to determine the planet's geological history and understand why it developed so differently than Earth. Orbiting Venus with a synthetic aperture radar, VERITAS will chart surface elevations over nearly the entire planet to create 3D reconstructions of topography and confirm whether processes such as plate tectonics and volcanism are still active on Venus. VERITAS also will map infrared emissions from Venus's surface to map its rock type, which is largely unknown, and determine whether active volcanoes are releasing water vapor into the atmosphere. In addition to 2 missions, NASA selected a pair of technology demonstrations to fly along with them. VERITAS will host the Deep Space Atomic Clock 2, built by JPL and funded by NASA's Space Technology Mission Directorate. The ultra-precise clock signal generated with this technology will ultimately help enable autonomous spacecraft maneuvers and enhance radio science observations. DAVINCI Plus will host the compact ultraviolet to visible imaging spectrometer built by Goddard. QVIS will make high-resolution measurements of ultraviolet light using a new instrument based on freeform optics. These observations will be used to determine the nature of the unknown ultraviolet absorber in Venus's atmosphere that absorbs up to half the incoming solar energy. Now, what can we expect to find on Venus? Well, certainly not aliens. This time, we are going to Venus to read every geological aspect about it. So, Venus is a hostile world. Its atmosphere contains sulfuric acid, and the surface temperatures are hot enough to melt lead. But it hasn't always been this way. It's thought that Venus started out very similar to Earth, but then something happened. While on Earth, carbon is mainly trapped in rocks. On Venus, it has escaped into the atmosphere, making it roughly 96% carbon dioxide. This has led to a runaway greenhouse effect, pushing surface temperatures up to 470 degrees Celsius. The planet's history makes an excellent place to study the greenhouse effect and to learn how to manage it on Earth. We can use models which plot the atmospheric extremes of Venus and compare the results to what we see back at home. But these extreme surface conditions are one of the main reasons planetary exploration missions have avoided Venus. The high temperature means a very high pressure of 90 bars, equivalent to roughly 1 kilometer underwater, which is enough to instantly crush most planetary landers. It might not come as a surprise then that missions to Venus haven't always gone to plan. Most of the exploration done so far was carried out by the then Soviet Union between the 1960s and the 1980s. There are some notable exceptions, such as NASA's Pioneer Venus mission in 1972 and the European Space Agency's Venus Express mission in 2006. The first landing happened in 1970 when the Soviet Union's Venera 7 crashed due to the parachute melting, but it managed to transmit 20 minutes of data back to Earth. The first surface images were taken by Venera 9, followed by Veneras 10, 13, and 14. Next time on Discover Zen, we will be discussing, is it possible to terraform Venus? Thank you for watching. If you liked what you saw, please click that like button and subscribe. Let us know in the comments below what kind of topic you want us to discuss. Until next time.